Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello, and welcome to another episode of the Chai Time Data Science Show. In this conversation with one of my peers from the fast.ai community, James Dellinger, who has a background in software product management from a startup called Peel and has been studying machine learning slash deep learning full time for the past 2 years. And recently, fast.ai as a full time student for the past 1 year. We talk about James' journey into machine learning slash deep learning, about image augmentations and an image augmentation library called DALI, spelled DALI, from NVIDIA. This conversation is based on James' article titled, quote unquote, Diving into DALI, How to Use NVIDIA's GPU Optimized Image Augmentation Library, to which you can find a link in the description of this podcast. Also, during our offline conversation, James mentioned that he's on the job market. So please feel free to reach out to him from his contacts linked in the description of this podcast. Here's the conversation all about image augmentations and the DALI library. Enjoy the show. Hi, everyone. Welcome to this special episode in our podcast series. Today, I'm joined by James Dellinger, who's also a Fast AI fellow. I've had the chance to know him through the community. We're going to be talking about image augmentation today and a library from NVIDIA that came out recently. It's called DALI. James had recently put out an amazing blog post, a deep dive into the library. I'll have the it linked off in the description of this podcast or the YouTube video. Please make sure to check it out. And thanks, James, for joining us today.
Yeah, thanks, Sanyam. Thanks, Sanyam. It's so great to be here and excited to chat about it.
Likewise. So let's talk about DALI. Like from NVIDIA's description page, it's sort of a image augmentation library. Specifically, like they mention it to be a data augmentation library.
Sure.
Can you tell us more about your understanding of it, and like we can also discuss why image augmentation is necessary?
Sure. Well, I guess I'll start kind of specifically with DALI first, and then we can maybe back up a bit to image augmentation in general. Why I jumped into DALI was I was going through the Fast AI notebooks from the most recent part 2, the 2019 version of Fast AI part 2. And I've just been going through notebook by notebook, and I got to the image augmentation notebook. And through that, Jeremy and Sylvain kind of walk us through how to implement kind of the basic, most important image transformations, such as random crop and resize, or rotation, or perspective warp.
And we implement that's from scratch, right?
And that's from scratch. We use Pillow for a lot of those. And what we found was that Pillow works really fast on like one image at a time. So it kind of like, I think definitely how I'd been doing my image augmentations before using OpenCV or Pillow is it, as far as I'm aware, it runs on the CPU and it does image by image in serial. And that's not an issue if you have a small enough data set or image set. But once you start trying to train like ImageNet or a data set with, potentially like 1 million images, and if you're going to do it from scratch, you'll start to notice over time that you're spending a whole lot of time on image augmentation, and you're going to want to see, is there any way to speed things up? Right. So at the very end of that, that class notebook we went through, Jeremy actually taught us how to use PITorch JIT to implement batch image augmentations using the GPU. And what we did was we wrote one script and it was for image rotations. And it would take like my batch size was 64.
Mhm.
So it would take 64 images, rotate each image at random, all at the same time on the GPU. And it ran obviously much faster than doing it image by image.
Yeah.
And so that was kind of where I was. And then I had been attending the in-person study group up at USF while the course was going on. And one day in study group, Jeremy kind of mentioned that NVIDIA had this library called DALI. And he showed us
Did you
a
attend the
little...
course in person?
What?
Did you attend the part 2 in person?
I did attend in person, yeah.
Great. Okay.
And so he kind of mentioned in passing, there was this library from NVIDIA, and he showed us this notebook that he and Sylvain were working on, but we didn't really have time to dive in it too deeply. And then we kind of moved on to the other notebooks and wrapped up.
Yeah.
And so a couple of weeks ago when I was here at home going through the notebooks on my own, I said, I remember that DALI. And I was like, I want to see if I can, how does it compare with doing PITorch JIT? Was kind of what I wanted to find out. And I wanted to know, like, is it as hard to implement? Do I have to write a script from scratch with 12 lines? Am I going to have to do a lot of research on forums? Because I don't really know how to use JIT. If I wanted to do my own, I'd have to, figure it all out from scratch.
Yes.
Or is there kind of a high level API? And so I went to NVIDIA's website for DALI that has a documentation for the library and stuff. And it looked really great. They were like, yeah, it obviously runs really fast because doing image augmentation as a batch on the GPU is kind of a no-brainer. Like, it just makes sense. To do a bunch of images at the same time is always better. So I was definitely sold on that. And then it said that it's also like has all the image transforms, at least the kind of the mainstream ones. And it's a really easy to use API. So I gave it a try. And then we can kind of go into more of the specifics of what that was like. But that was sort of how I got to the point of like, why am I exploring this?
Got it. So like you mentioned Pillow. Like, do you know if it's just fast.ai? Because I know for sure that fast.ai bakes in all of the best practices,
Sure.
most of the cutting edge practices. So like people are telling ImageNet all of the time, even before DALI came out, right? So
Sure.
was it using just Pillow or JIT like scripts?
That's a great question. I don't know. If I were to guess, I'd say like, given that we started off learning how to do it in Pillow, and I don't remember for sure, but I think I remember Jeremy saying like, most people don't do it on the GPU.
Okay.
My impression was most people are just doing it on the CPU.
Yeah. Even the fast.ai library, I believe it's on the CPU so far.
Sure. Yeah. Yeah.
Right. And the main reason we'd want to use the GPU is because it's too damn fast compared to the CPU, and like we definitely want that to remove that bottleneck. Part 2 that comes out in June and is going to be talking about all of these cutting edge practices, like how do we remove this bottleneck, how do we make sure that we're using every performance out of our model. So I guess that's one of the reasons why we want to use this.
For sure. For sure.
Right. And another point I want to ask you is like, if DALI isn't there, how is just using JIT just-in-time compiler by PyTorch like for this?
Yes. So that's like, so definitely if I ever wanted to do an image rotation on the GPU as a batch, I know I can do it because I already have that implemented. Okay. So I've got this great template from fast.ai from the course. But if I were to want to, say, implement warp affine transforms from scratch, I'm sure it's possible. But it's not clear to me exactly for someone like me who's maybe has about 2 years of Python experience, how, and maybe like I have probably about a year of PyTorch experience. It's not clear to me how long it would take me to kind of learn the ropes of JIT and kind of use that image rotation thing as a template and then glean as much as that as I could, but then do kind of a completely different algorithm. I know Jeremy has mentioned that JIT can be kind of finicky. He says it's improving rapidly, getting better like day by day. Yeah. But when we saw that script in class, it had kind of already gotten to the point of like, he'd already debugged it and he and Sylvain had polished it and it sort of just worked. And so he intimated that getting to that point of having it quote unquote just working was not super easy. Now, how long that would be for me, like, I don't know. But it would
Got it.
definitely be an interesting exercise.
Interesting. Uh, so tell us more about DALI. What I know we run a lot of experiments on it,
Mm,
and how's that been an experience compared to the JIT script you mentioned?
sure.
And I know that it must have been a lot better in terms of performance compared to Pillow.
Sure.
How about the general interface and the general explorations?
Sure. So I felt like the general interface of DALI was awesome. I felt like it was really straightforward. Um, Working with DALI, you have to do two things. You have to write a pipeline class,
Right.
and that basically, it's a class and its subclasses, or it inherits from a DALI class that's actually just called pipeline.
Mhm.
And inside your class, you just include a line for basically every transform you want to call. And that pipeline class, it has two methods that you need to define. The first is just a normal init method.
Yeah.
And in that, you just create objects or variables for each of your transforms, say image rotation, image resize, etc. Then there's one more method called define graph. And if you've ever worked with like TensorFlow or V1.0, this might start to feel familiar for you. You just kind of, you put in a line for each of your rotations in the order you want them to be called.
Right. So it's more on the side of static graphs from what.
Very much static graph.
Okay. So
And so
more TensorFlow than PyTorch yet.
right. And so another good thing about DALI is it works really well with, well, I didn't try it with TensorFlow, but all the examples on the website and the documentation lead me to believe it just works with TensorFlow. And I felt like it kind of just works with PyTorch. It's supposed to return data loader objects that PyTorch can understand. Getting it to work with fast AI, especially the library that we were building from scratch during part 2,
Yeah.
that required a lot, probably like 10 hours of troubleshooting time on my own, not because it was really complex what I had to do. It just took me a while to kind of go through and figure out, where is it breaking? Okay, where is it breaking now? Like, what class do I need to go back and fix? And it actually turned out there were just 3 simple fixes I had to do to get DALI to work really great with the fast AI that we've been working with in part 2.
Yeah.
But it was that exercise of going in and hunting down what I had to do that took me personally a while to kind of figure out what was going on. A nice side effect of that was that because I did that, it really forced me to understand the ins and outs and the plumbing of all of those classes we had been implementing from scratch during fast AI part 2.
Got it. So I assume like this would also require a lot of expertise with the library that you must have gotten through by going through the part 2. And how about interfacing with it in general? So for example, I'm working on a pipeline at work and I want to just maybe give this library a shot. What are your thoughts on that?
So if you have, I feel like I plan to use DALI going forward, but I would use it for early prototyping when I just want to, when speed is kind of the name of the game. And I'll get into why in a second that is. If I were if it were the final week of a Kaggle competition and I just wanted to squeeze out that extra like 0.0001 point of performance or something like on my CV, I probably wouldn't use it. And here's why. DALI does support kind of all the basic transforms: rotation, image resize, or random crop and resize, which Jeremy mentioned is the most important one because he said all the ImageNet winners, like as a rule since like 2013, I think it was, have some form of random crop and resize.
Yeah.
Each one of them, that's their augmentation. And then some of the other ones vary. But my goal with working with DALI was to say like, okay, does this at least have the augmentations that we implemented from scratch in part 2? And so that was random crop and resize. It was image rotation. It was warp transform. And it was flips, like random horizontal or vertical. And so, and also each of these, in order for me to consider DALI like quote unquote supporting it, it needed to support randomized output. Meaning if I said rotate images, I can give DALI like a range of angles. And for each and every image in a batch, it will kind of do it just a little bit different. And because that's what we had implemented from scratch and kind
And
of.
like, could you elaborate on why is the randomness useful? So if I just give one angle, why is that not enough? Or if I just put queue in a few angles, 30-degree, 40-degree, why isn't that good?
Sure. Sure. So having randomized output will help the model that we train to generalize better to the test set or to brand new unseen things. And so the reason for that is if I'm always like looking at, say, a truck, and the truck is always like not tilted, not anything, then my model can get really good at understanding what a truck looks like, but the truck better not be tilted, it better not be fuzzy, it better just be like a perfect picture. But in real life, you know, maybe the camera tilts a little bit, or maybe like you're looking at from underneath, and really like you could be looking at an image from any sort of angle, who knows?
Yeah.
So that's why when we do these transforms, we like to perturb them a little bit, maybe tilt the image this way or that way, rotate it this way or that way, and kind of, at least for, it's a little bit different for other image sets like satellite imagery, but at least for the ImageNet stuff, when it's kind of an image that's just facing you, we like to see what it's like to look at it through kind of different lenses or different angles. We don't really like to, we don't want to perturb it, like we don't want to squish it or stretch it in a way that would be really unnatural, that like you would really never have an application where you needed to first take a truck and stretch it really wide and then like know that it's a truck.
Yeah. So again, like I assume you'd have to have the knowledge of all of these transforms and maybe some expertise, or at least knowledge of your data and like understanding of how these transforms would apply to it and give you output.
Absolutely. Yeah, that's definitely one thing that DALI has it all in there, but it doesn't have any sort of logic to kind of know, oh, what kind of ImageNet or what kind of image set you have and what kind of transforms you might or might not want. It's definitely not at that level. It kind of expects you to be more of a practitioner who's kind of knows what transforms you want to use ahead of time.
Contrary to fast.ai, because fast.ai, I've done a deep dive into the existing ones, and it has good enough defaults for most of the cases. So fast.ai takes care of the defaults for you, which, like you said, just works quote unquote for most of the cases.
For sure.
Right. You mentioned about ouncing out performance, for example, during the last week of Kaggle, or if you're putting this into production, you definitely want to use most of the performance. So
right.
Usually we'd be using, I believe, C++ pipelines for that, or some other alternative. Do you think this could be used in production as an alternative to it, or is it still in the early stages for that?
My understanding tells me there is no reason why it couldn't be used in production. The reason is because although we, tell DALI what kind of pipeline we want to have and how we pass hyperparameters to the different rotation transforms, we do all of that in a Python API.
Yeah.
Everything is written in C++. Everything is optimized for the GPU. So at least assuming that, again, if we're talking actually the documentation on the website did seem to indicate that even if you had a bunch of like GPUs, it would work with all of them and figure out how to distribute the batch across all the GPUs as well.
Is it mentioned, is that manual or that's taken care of by the library?
Good question. I don't know.
Okay.
I don't know. I would have to go back and double check in again. I do remember saying that it supported several GPUs, but unfortunately from my experiments, I just ran it on one GPU. So I wouldn't know if it would automatically know all of that, or if you'd have to say, hey, DALI, here are all my GPUs. Or if it just knows to go in and check and see check in your system or your CUDA and see what you have.
Got it. Another thing you've done is you've really benchmarked this, and you share the results in your blog post also. So I believe you benchmarked this against both JIT and Pillow. How does it compare to both of these in your experience?
Sure. So it was tough for me to I guess, do a true apples to apples benchmark with Pillow, because with Pillow, we kind of go image by image. And Pillow, on average, most of those transforms would do one image in like a couple hundred microseconds.
Right.
And for when I timed DALI, I could see how long it took to run all of my transforms on one batch of 64 images. And if I did like the dimensional analysis and divided by a number of transforms divided by a number of images, it worked out to something like 600 microseconds per image. So in that regard, you could say it's quite comparable.
Right.
However, one thing we found was that with Pillow, the main bottleneck is loading up those images for the first time. Once you have the image loaded and you do transforms, it's fast. But just loading up that image initially can take like 5 microseconds, at least on my AWS. And to me, that just was like, yeah, if I'm taking this long to load each image, then I could never, Pillow would never even approach DALI.
To our listeners, millisecond might sound a very small gap, but when you're doing millions of images, it really gets accounted for. You'd want that to be in micro, if not hopefully someday nanoseconds.
For sure. And then as far as comparison with PITorch JIT, I found that PITorch JIT could do the one batch of 64 image rotations in about 4.3 milliseconds. And it took my DALI pipeline of, say, I think it was about 11 or 12 operations. Of course, not every operation was run on each image because, again, these were applied randomly. Some images would get rotated and some wouldn't, for example. But all in all, it took one batch with about 12 operations, about like 40 milliseconds. And if I divided that by, like, say, again, back of the envelope, but just divide by 10, or that's like about 4
milliseconds.
Yeah, right, per operation. And that's kind of reminds me of my 4.3 milliseconds it took to do my rotation on my one batch using PITorch JIT. So I felt, I can just say it seems pretty comparable. It's pretty similar. And that was pretty reassuring to see. We should probably get to sort of like the one kind of, at this point, I think folks might be saying, okay, great. DALI is like perfect. It's like ready to go. It's easier to implement probably than a JIT script. So why wouldn't anyone use it?
From what I've understood, we've also mentioned that it's more TensorFlowy. So for our fast AI friends or people who are fans of the PyTorch approach, the TensorFlow 2.0 approach also, how do you think DALI is a good complement to that?
It's funny. I guess no, it's not. If you're super in a PyTorch dynamic mode. For me, I mean, I've pretty much been only doing PyTorch for the past year. Before that, I had some intro experience with TensorFlow. And then kind of, I'm much more into user friendliness. So then once I got to PyTorch, I was like, okay, I don't see why I would go back to the old, at least TensorFlow 1.0 style. But even for me, who had a little bit of that experience with creating the static computation graph, I had to it was sort of a little bit of a, what do you call it? Culture shock, getting back into doing that again with DALI. Not surmountable. It was not insurmountable. It was totally doable. It just took me kind of persevering through a little frustration and some strange runtime errors.
Got it. So how I look at it is, to conclude, DALI does have all of these great options. There's some non-ironed out ends. For example, you can't do randomizations. And but could you envision it if you're working with this, you might be at a expert level, or you really trying to put this into production? So do you think it's a good option just for that particular use case, maybe not for an experimentalist?
Right. Unfortunately, maybe given where the library is currently at, the one irony might be, while it's not suitable for, say, someone who's a domain expert and kind of picking up, maybe they're a few months into their deep learning journey, and maybe they're not quite ready to pick each and every image augmentation on their own. That kind of person, DALI is not suitable for them yet, because DALI really wants you to know exactly what you're going to do and in what order you're going to do it and what parameters you're going to pass to it, such as I want to rotate my images between plus or minus 30 degrees or plus or minus 7. Like you, the practitioner, need to know that.
It's very manual.
So that kind of, in my mind, that means like, okay, DALI really isn't appropriate for just kind of domain experts fresh into deep learning. Ironically, on the flip side, I would say DALI isn't really appropriate for experts who want to put a cutting edge model into production. What I mean by that is because, and this was in my mind the biggest kind of downside of DALI, not all augmentations support randomized output. So we spent some time a few moments ago talking about image rotations and why we want it to be random, so we can see all the different angles. You know, our model can learn to look at a truck from all the way around. Well, it turns out, while like horizontal flips, vertical flips, image rotations, they all support randomness.
The most common ones that are.
Sure. Warp affine transforms or perspective tilts. And a warp affine is basically something that it makes it look like, imagine you have a framed image on your wall, and the image begins to kind of like, or the painting begins to tilt toward you or tilt away from you.
For example, if I have my iPhone and that's getting tilted in a 2D image. Got it.
For sure. And so what that does is it's still a 2D image, but it looks kind of like, oh, this truck is sort of falling out of the screen. We would like those to be randomized as well, and DALI doesn't support that.
Because we fast AI fellows and we're talking 2019 cutting edge deep learning, and these I think are most of the cutting edge practices that are being followed everywhere in 2019 for sure.
For sure. And so it for that, and I think there may be one or two other transforms that DALI also doesn't support randomization. And so this was the point at which, when I went through and built my own pipeline, I was like, okay, I want to implement each of these 4 transforms that we learned how to do in fast AI. Okay. And then instead of just like, I didn't want to skip having warp transforms or perspective warps. I wanted to do it somehow. And I thought, okay, fine. DALI doesn't have logic to randomize it, but no problem. I'll write my own. We kind of learned how to do that even in class. I'll just write my own Python method and just call it, at runtime from within my pipeline. No dice. Do not try that. That is not static graph programming, as I painfully found out. And what I kind of, after hitting my head against that wall a few times, I went to the DALI website and saw that it was a known issue. Folks had even requested that the team add randomization to some of these other transforms. And the response from the team was, we don't have the bandwidth to do that right now. If you want, you can create your own custom operation. And I said, okay, how do I do that? And it turned out DALI really is written in C++, which I think is a good thing, because that means it's optimized for the GPU. It's optimized for CUDA, but for me personally, it was a bit of a bad thing, because I was like, okay, I need to write this logic in C++, compile it, and then import it so I can use it in my DALI computation graph. And then that was a little bit more than I wanted to invest.
I think that's even a stretch for most of the practitioners, because even for the production use cases, I believe if we're talking to different frameworks, we might expect another team to be taking care of the C++ side of things out there.
For sure. So that was kind of the main downside.
Got it. So how I imagine this would be, you already, like if you're doing experiments, mini experiments or such, a CPU should be good enough for you. But if you're working on a problem that works and you just need the augmentations that are there inside of this library, it could be a great option for you.
I definitely think so. If you just went into say you just didn't even really want that many image transforms, you just wanted to resize your images or do random crop and resize, then it might very well be enough.
For most of the use cases, I believe the generic apps, hot dog, not hot dog, whatever be the thing, these are good enough, I think.
Sure, for sure.
And maybe like again, it's the flip side is you would want to put this on a GPU. So usually when we're talking production, everyone is putting it on a CPU, not a GPU. So it's really for the practitioner who wants to train on a million images.
Correct.
Just these options that are currently supported, I believe. In the future,
Right.
hopefully they might roll these out.
It was interesting. The ticket for adding randomization to the warp-affines on the GitHub, the team definitely, I could tell that they looked at it, but it seemed like, at least for the time being, they made a firm decision not to do it. But I mean, on the bright side, they're totally welcoming contributors to come in and add it to the library. So if you know C++ or you want to learn a little C++ and you really have a passion for building image transforms from scratch, I think they would really welcome it. But I didn't, like, the ticket was closed in February, and it's not clear to me that it's coming in the next version. Who knows? It may, but
maybe in a future ish release, hopefully.
Sure.
Got it. Thank you so much, James, for that amazing introduction. I have James' original blog post linked in all of the descriptions, along with his experiments. You can also find James on Twitter or any other place where you can follow your activities.
I would just, Medium, Twitter. Those are probably the two best places. Yeah.
James also has an amazing blog. I'd encourage you to check out other blog posts as well. We'll have all of those linked in the description of both the YouTube video and the podcast description.
Sounds good.
Thanks again, James, for joining me today.
Thank you so much, Sanyam. It was awesome.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.